I'm going to teach you how to simplify expressions with exponents. And here's some examples down here. Now, by the end of the lesson, you'll be able to just look at these and write down the answer. This one's just going to be x to the 7th. This one's just going to be x to the 6th. Here you look, it's just y to the 3rd. And this negative exponent just becomes a fraction. It's 1 over 2 to the 3rd. Of course, 2 to the 3rd is 8, so the final simplification is 1 over 8. Let's do the first one. Multiplying algebraic expressions with exponents. Well, let's go ahead and expand this. X to the 3rd is x times x times x. X to the 4th is x times x times x times x. And you have 7 of them altogether. It becomes x to the 7th. And another way of looking at this is x to the 3rd times x to the 4th is x to the 7th. You just add 3 plus 4. Let's try another one. 3 times 3 to the 4th. That's 3 times 3 times 3 times 3 times 3. And altogether you have 5 of them, so it's 3 to the 5th. Again, another way of looking at this is you put a 1 for your exponent if there isn't one, and you add 1 plus 4, and you get 3 to the 5th power. Same answer, no big deal. And by the way, when you multiply all those 3's, 3 to the 5th power will give you 243. Now we're ready for another one. Now this one's a little bit tougher. Well, we can still expand it out. X to the 3rd is x times x times x. Y to the 4th is y times y times y times y times another x times y times y. Now we just got to count how many x's and y's there are. There's 4 of them, so it's x to the 4th. And there's 6 of the y's, so it's y to the 6th. And again, you can just add up the exponents. 3 plus 1 is 4. And 4 plus 2 is 6. Let's go ahead and look at a different example. Let's try raising a power to a power. We have x to the 2nd power to the 3rd power. Well, that's the same as x squared times x squared times x squared. Now you can use the same principle we've been doing, just add them all up. But I'm going to go ahead and expand that for you. X times x times x times x times x times x. And it's x to the 6th. Well, the quicker way of doing it is just to multiply. 2 times 3 is 6. That's going to work. You just multiply those exponents times the one on the outside. Let's try this one. 2x to the 4th times 2x to the 4th. I'll go ahead and expand that one. It's 2 times x times x times x times x times 2 times x times x times x times x. Then just multiply everything together. 2 times 2 is 4, and there are 8 x's. Very simple. Now again, you can put that 1 if there's not an exponent, and you multiply times all the exponents by the 2. So it becomes 2 to the 2nd and x to the 8th. And of course, 2 to the 2nd power is 4, so again it's 4x to the 8th. Let's try this one. Might seem a little more complicated, but it's the same basic principle. You take what's inside the parentheses and multiply it times itself 3 times. And if you want to understand what's going on, you just expand it. 3 times x times x times y. Do that 3 times. And then just multiply everything. 3 times 3 times 3. It's going to give you 27. There's 6 x's. And there's 3 y's. You're done. Again, the quick way of doing it is to multiply times all of the exponents. Again, that y would have an exponent of 1. So you have 3 to the 3rd power, x to the 6th, and y to the 3rd. Of course, 3 to the 3rd power again is 27. Right out of room. That's my final answer. They're the same. No big deal. Let's try dividing algebraic expressions with exponents. Well, when I expand this, it's y times y times y over y times y. Well, y divided by y. Y goes into itself 1 time. So I can just cross them out. They just become 1's. Y times 1 times 1. And that, of course, is just y. You just cancel them out. You subtract them away from that. Technically, it's not subtraction, but you're going to subtract the exponents. 3 minus 2 is just 1. You're taking away those whenever you cancel them out. Let's try another one. Just simplify the parts. I'm going to expand it out again. 4 times 5x's. 2 times x times x, and then simplify 4 divided by 2 and cross out your x's. 4 divided by 2 is 2. Cross those out. I'm left with 3 x's on the top, x to the third. I don't really need to write it as a fraction anymore, but I just wanted you to understand that there's something left on the top. We can do it this way by dividing 4 divided by 2 and then subtracting 5 minus 2. 5 minus 2 is 3. Same exact answer. Again, 4 over 2 is just 2 over 1. So that really is a fraction, but it's the same exact answer, 2x to the third. Let's try it again. We can write them all out so we understand what's going on. That's a lot of m's. 4 m's and 5 n's. And on the bottom, we're going to have 2 m's and 1 n. And just cancel things out. They just become 1s. M divided by m is 1. N divided by n is 1. Whatever's left, that's what you write. M to the second and n to the fourth. Of course, again, you can just subtract. 4 minus 2 is going to give you 2, and 5 minus 1, remember that's n to the first power, that's going to give you 4. Same exact answer. Well, what about negative exponents? Well, let's see what happens. You guys already know how to do a problem like this. X to the fifth divided by x to the second. You just write out all your x's, cross those out, and you have x to the third. That's on top. And when you do the short way, it's 5 minus 2 is 3. X to the third, no big deal. But what happens if the exponent is bigger on the bottom? X squared divided by x to the fifth. Well, let's expand that out. X times x. And 5x is on the bottom. And we're going to have a little placeholder, a 1 times 1. No big deal. Just when we cross these out, we need something to still be up on the top, and a 1 is a good placeholder. We're left with 1 over x to the third. Well, what happens if we subtract those exponents? 2 minus 5 gives you x to the negative third. When you have a negative exponent, you take that and put it on the other side of a fraction bar, and the negative part goes away. It becomes 1 over x to the third. Let's try another one. Again, let's do this one both ways, both by expanding it and by subtracting. And you got 3 2's on the top, placeholder of 1, 4 2's on the bottom. I'm just going to cancel things out, see what's left over. 1/2. You have a 2 on the bottom. Notice there's 1 extra 2 on the bottom. Well, 3 minus 4, that's going to give you an exponent of negative 1. That's the same as 1/2. They mean the same thing. Hope this is making more sense. Let's try this tough one. Now, I'm not going to use my bad handwriting. Let's go ahead and write that one out this way. Simplify 8 over 2, 4 over 1, and just cancel things out. They all mean 1. Cancel out, then count what's up on top and what's on bottom. There's a 4 and an x on the top. And there are 3 y's and a z on the bottom. You're done. That's it. It's just that simple. Let's do it the short way. Simplify 8 over 2, 4 over 1. You don't really need to write the 1 this time, but let's do it anyway. We subtract, but you notice there's an extra x on the top. So you just leave that after you cancel it out. 3 minus 2 is 1 on the top. There's 3 extra y's on the bottom. So you leave those 3 on the bottom. There's 1 extra z on the bottom. So you leave that on the bottom as well. That's just one more way of getting the same answer. So I hope this makes a whole lot more sense now. You know that to multiply them, you just add the exponents. To raise a power to a power, you're just going to multiply the exponents. When you're dividing them with the same base, they're both y's, you just subtract. 5 minus 2 is 3. And anytime you have a negative exponent, put it on the other side of a fraction bar and the negative magically goes away. So I hope it makes a whole lot more sense after expanding them and trying the shortcuts.